This video is on iteration. First thing we need to find out is when do we actually use iteration? We use iteration when equations are too hard to solve. So we've learned things like the quadratic formula, we can solve quadratics, but sometimes they're even harder than that and we don't have the skills yet to solve them. So something might look like this. We don't actually know how to solve that. We don't know what the answer x is yet. And in that case, that is when you then turn to iteration. Please help us, even if you're irritated. When you're solving equations that equal 0, just like this equation here, you know there's a solution within a region if the sign changes, the sign being positive or negative. And that fact there is really super duper important, and we'll just use it now. So if I take this example that I said we couldn't solve, I could say, show that there is a solution between x equals 1 and x equals 2. And I know that there is a solution between x equals 1 and x equals 2 if there is a sign change, because from our statement, if the sign changes, there is a solution. So the first thing I'm going to do is substitute x equals 1 into this equation. And that gives me 2 times 1 cubed is 2, minus 1 squared is minus 1, minus 3. And that gives me an answer of negative 2. Now I'm going to substitute x equals 2 in. And that gives me 2 cubed is 8 times 2 is 16, minus 2 squared is minus 4, and minus 3. And that gives me an answer of 9. So as we can see here, we've been asked to show there is a solution, and we can see it goes from negative 2 to positive 5. So there is a sign change, so there is a solution. So that's all you have to write down in your exam, that's what you've shown. These 3 dots mean therefore it must, because we're quite lazy. So let's just think about the fact that there is a solution as the sign changes. Let's think about, instead of just remembering that, how that actually works. So if I look at a number line, here is my number line, and the answer I want is 0 because this equation equals 0. And I just showed that when I substitute x equals 1 in, I get an answer of negative 2. So let's put that there on our number line. And when I substitute x equals 2 in, I get an answer of positive 9, so over here. So somewhere, we've had a sign change, so we've passed the answer we want, so we've gone from negative 2 to 9, so it must be in between here, because this is the answer we want, 0. Therefore we know our solution, so our x value must be between the x equals 1 value that gives you minus 2, and the x equals 2 value, which is 9. So it must be a solution that gives me 0 between x equals 1 and x equals 2. So that is why a sign change is showing a solution when an equation equals 0. So now let's move on to some exam questions. Okay, so this is an example of an iteration exam question. So the number of people living in a town in 2 years from now is big P little t, where P0 is 55,000 and P2 plus 1 equals, and it's given you a formula, 1.03 brackets PT minus 800. Work out the number of people living there in 3 years. So what would that be? If we read the question, the number of people living in a town in 2 years from now is PT. So we are looking for P3. Okay, how are we going to find P3 using the information it's given us? So firstly, we know we have P0 is 55,000. So what about if I want to try and find P1? That is, I want this to be 1. So I've got t plus 1 equaling 1. So if I solve for t, I take the 1 over the other side and it becomes take away 1. So I have 1, subtract 1, so that gives me t equals 0. And I have when t equals 0 because I have P0. What I can do is I can work out P1, and that is going to be when t equals 0. So using our formula, 1.03 brackets t we know should be 0, so we substitute t is 0, so this becomes 0. That's the point there, so that was t equals 0 for this one, minus 800. Okay, and we know what P0 is because we've been given it, so. And that should give me an answer of 55826. So we now know that P1 is this. So now let's try and find P2. So the number of people in the village after 2 years. So if I want P2, I need this t plus 1 here, this little subbit, to equal 2. So if I solve for t, I'm going to take the plus 1 over there. So it's going to do the inverse operation, so I'm going to subtract 1. So 2 subtract 1 gives me 1. So now I need to know that for P2, I need to substitute in t equals 1. So let's have a go at that. So here's our formula, 1.03 brackets P, but t is 1 in this case, so P1 subtract 800. So as you can see, we've just worked that out. So this is kind of why iteration is irritating, is instead of writing P1, I'm going to write answer because it's important to leave your answer on the calculator when you're working with things like iteration. Subtract 800, and that is going to give me 5676.78. So that's where you can see it's very important to leave, don't round that yet, basically. So now let's look for P3, which is the one we're actually after, but we have to do all these steps to get there. So when I'm looking for P3, I want that little subscript, t plus 1 to equal 3. So if I rearrange and solve for t, I take the 1 over there, so I do 3 subtract 1, which gives me 2. For P3, I take t as 2. So in my equation, I have 1.03 multiplied by pt, but t is P2, subtract 800. And we've worked out P2, and this is why you don't round. You leave that answer in your calculator, and you just put 1.03, and then, careful, put the answer button on your calculator, subtract 800. And that gives me an answer of 57553.0834. Now, I'm talking about people, so I can't have point of a person. So therefore, I'm going to have to round this to the nearest person. So that is going to be given an answer of 57553. So that's how you work out iteration. It's kind of using previous answers, and you've got to get used to using that answer button on your calculator. And the hardest part to understand is trying to find out what t is and understand that if you want a subscript of 3, you have to set t plus 1 equal to 3. So let's do another example. Okay, so this is our next question. Using x subscript n plus 1 equals 5 over xn squared plus 3 and x0 equals 1, find x1, x2, x3. So we know that x0 equals 1 and we're looking for x1. So for to get x1, if we look at that, we want this little subscript n plus 1 to equal 1. So we're going to have n plus 1 equal to 1. So if we rearrange for n, you take the 1 over that side, so 1 subtract 1, so that is 0. So for the x1 case, n is equal to 0. So if we can substitute that into our equation, we have 5 over an x0 squared plus 3. And we've been given x0 squared, so we can keep going. So we have 5 over x0, 1 squared plus 3. So that is 5 divided by 1 plus 3, which is 5 over 4. Okay, so we found x1. What about x2? So for x2, we want this little subscript, the n plus 1, to equal 2. So if we rearrange for n, we take the 1 over the other side of the equal sign, do the inverse operation. So we do 2, subtract 1, so n is equal to 1. Okay, so now let's follow the equation it's given us. So x, but then n, so it's going to be x1 squared plus 3. So let's substitute. We've just found out x1, so we can substitute that in. So you can do your answer, which in our case was 5 over 4 squared plus 3, and work that out. And we get 80 over 73, which is 1.095894 Don't round your answers either, leave them as really long ones. Okay, so we have one more to find, and that is x3. So what we're looking for when we're trying to find x3 is we want this little xn plus 1 to be, so we want that little subscript to be 3, so we want n plus 1 to equal 3. So we're going to have n as, take the 3 over, n is equal to 2. So let's copy this out, so we're going to have xn, but we know that's x2 squared plus 3. And we know what x2 is because we've just put it there, and as you can see it's very complicated, so make sure you put the exact answer in squared. So leave it on your calculator and put the exact answer in squared, otherwise you're going to have rounding issues. And the answer you get is 1.190199669. So that's how you do that type of question. Okay, so the first part is show that 2x cubed minus x squared minus 3 can be rearranged to give this. So basically you've just got to try and mess around with rearranging this equation to get that. Now the tip I would say here is I can see a squared root, so I know I'm going to have to square root at the end. So if I take out a squared factor to start with from this, I'll write it up here. Take out a squared factor, x squared from this bit, I'm going to be left with 2x here and a minus 1 for this term. So if you do 2x multiplied by x squared, you get 2x cubed, and x squared multiplied by minus 1 is going to give you minus x squared. Okay, so now let's take the 3 over, because now we're trying to solve for x. Let's get rid of this. It's multiply on this side, so it becomes divide on this side. So you're going to have x squared equals 3, all divided by 2x minus 1, the whole thing. And then we've got squared and we just want x, and it's looking, we like keep assessing this at the same time. It's, yeah, it's looking quite similar. Square root, do the inverse, so square root on the other side, and that's how you get the answer. If you don't get it straight away and you try to solve it and rearrange it a different way, just do trial and error and keep going and try different ways until you get the one they want. Okay, so we've done that, and now there is a second part. Okay, so this is now the second part. So starting from x0 equals 1, use the iteration formula twice so we don't have to do it twice. There's the formula, n plus 1 equals, so it's exactly the same as that, but with the n's, to estimate the solution 2. So first we have x0 equals 1. So our first go, so we've got to do it twice, is x1. So that means we want this to equal 1, so n plus 1 to equal 1, so n is 0 in our formula. So x1 is going to be 0, n is 0 in this formula, so we have 3 equals 2, x0, subtract 1. And we know x0, so we substitute that in for 3, 2 multiplied by 1 minus 1. And that is going to be, so 2 minus 1 is 1 on the bottom, so that's just going to give root 3. So we've done it for the first time, let's do it twice, second time. We're going to be looking for x2. So this time we want this little subscript to equal 2, so we have n plus 1 equals 2. If we rearrange and solve for n, you can take the 1 over, so you get 2 minus 1, which is 1. So for this, in our equation, n is going to be 1. This one, it was 0. So if we substitute n is equal 1 into the equation, you have 2x1 this time, minus 1. And that's going to be the answer to your previous question that you're going to just put back into your calculator. So if I just work that out, and the answer is 1.1033957, blah, blah, etc. So yeah, don't forget to round. So I hope you've had a lot of practice of iteration now.